Welcome to Science by Design. My name is Tom Curry. I'll be presenting on the benefits and pitfalls of AFL in middle school science. The reason pitfalls is starred is because they're my pitfalls and my benefits, and I wouldn't presume that anyone else had the same ones. AFL, for those of you who may not know, is an assessment for learning, a utility designed to help us summate and formate the marks in our classrooms. Down at the bottom, you can check out my Twitter feed at Dramatic Science and the hashtag for this conference, ACSI Teach 2011. This is just a web shot of the front page as you come to the website for grades 7, 8, and 9, just for pulling together all the information that I think the students will need going forward in the course of the year. This link here is just a zoom in of the sidebar. This is what students see and how they navigate the site. There's a couple key features. The Science Sandbox I will talk about at the end of the presentation, and the FAQs I don't talk about much, but certainly they're worth bringing up at some point during the presentation. The starting point is what we do and why'd we do it in grade 9. So let's move on to there. What we did and why we did it was a student-generated project where each week they were expected to go in and collaborate much like they would on a wiki, adding their thoughts to what the course over the week was about. Generally speaking, we had 5 different periods, so there can be anywhere between 1 or 2, 3, 4, 5, 6, 7, 8. You know how science goes. There can be a lot of topics covered in 1 week. The idea is to force students to repeat back to us what was done in class, to reflect on what was done. That was the why did we do it, and to recognize it. When you put it into words, when you take what was in your brain or in your notes and you summate, that metacognitive activity tends to log it in our brains. And so this is a really useful resource that I'm sad to say was poorly managed, and so it fell out of fashion by about mid-November. However, it is a process that I think is really meaningful. It's simply getting the discipline into the students that they need in order to continue it. I want to tell you about some foundational elements. Every unit in the science curriculum has a list of I can statements pulled from the Alberta Program of Studies. This is the section that students would see for chemistry. You notice there's only 5 I can statements for chemistry. These are things that I looked at the curriculum and said if we had to look at the 5 umbrella ideas, the 5 things the students must be able to do, encompassing all those other key elements of curriculum, these are the ones that I would have come up with. And these will steer my projects as I design the lessons for the unit and design the projects for the unit. And they also allow the students a check-in point. If they can answer these questions and understand the glossary of terms that is within this, it's a good indication that they are in fact following along with the course. Looking at the structure of each unit is really important. This is the structure of the chemistry unit for the grade 9 students. It's a table format. It's a quick look. Each link becomes highlighted or available as students come to it. And the resources that they might need to hyperlink to the shortcuts, as it were, as they're studying, are listed for them, as well as due dates or end dates for the lessons and the assignments, and a link to the I can statement, so they can always remember that each one of these is connected to something that they are meant to be learning for the Alberta curriculum. Looking at each one of these things, these match fairly closely to what you might see if you were to go back and look at the I can statements. And again, this is not only the lecture notes that I'm having in class, the assignments and worksheets that are given out, the videos and web utilities that are being used, but also a place for students to capture where they're at and why they're doing what they're doing. This is very strategic, it's very specific, and the curriculum is spiraled. So we start with the simplest properties of matter and come back to that again when we start talking about atomic theory. You can't do the last lessons without doing the first lessons. Assignments within the chemistry unit are varied and diverse. The important things about them is that they're both digital and analog, so the students would get a copy of this in class as well as be pointing towards it in the wiki. This is great for students that miss class a lot because they can follow along with where we're at as it gets published online. And it's also great for students that have a difficult time with technology for whatever reason. Most, if not all, of the activities are project-based, meaning we learn the material as a sort of a research project in the beginning. We do a couple test assignments in the sense that they go out and try out their learning in a practice method, and then they're asked to come back and do something completely new with it, something that they haven't seen before, so they can translate what it is they think they've taken in into something meaningful in their language, allowing me to formatively assess where I believe they're at in the journey to mastery of each topic. These are very comprehensive assignments. Students often get a little bit boggled at first. Oh my goodness, there's 4 pages to this. But it's also very well set up with the typical headers so that students can follow along. And this is just a snapshot of one of my favorite activities from the chemistry unit. Also, these assignments are designed for class time. It's incredible the amount of homework that students can get in science, and I try and minimize that as much as possible. Again, with grade 9 students, there can be lots of students who are focused in on task and they get the assignments done in the class time, and then of course there are lots of students who waste class time quite effectively. But they are designed to be done in class time, and anything that's done at home is a bonus to them, bonus time that they spend. When we're looking at assessment of what they're doing in terms of these can-do statement, it's mastery learning. So they're expected to get a green light in all activities. And those green lights are translated into their summative mark. 60% of their unit is calculated based on the number of green lights they get. You can look, it's a scoring system. It's really just a pass-fail system when you get right down to it. Red meaning it wasn't submitted, or what was submitted was not the assignment. Yellow meaning there is something there that's missing that I think that the student should be able to complete and needs to be able to complete in order to be considered complete. The assignment needs to be considered complete, and then a green is what's there is great evidence that the student has learned the ideas that have been put forward. This is an online table that all of the students see at the same time. They can see each other's work as they go through this. These are not test results. These are simply, did these students go through the process and turn in something that is complete? And in its completion, it should not have any errors in it. It should not have any missed ideas in it, because these needs to relate to the can-do statements. Students are also able to hand in their assignments in class. They find that the benefits of handing it in online is it gets marked quicker. It's easier to rewrite and turn things in. Once they hand it in, often out of book, out of mind type of thing. When it's online and they're constantly working with this table, they're seeing their colors and they're getting a sense of where everyone is at with it. And one of the great fallouts of this as well is that students see that even the real top students that they've been following for years don't get it right the first time, and they love to see the mighty fall, in a sense that, oh look, so-and-so got a yellow light on the first try, and so they aim to get a green light in the first try, which means they're starting to aim to complete assignments fully and completely. However, as I'll get into later, it doesn't always work that way. Yellow work might look like this. It's never an endpoint, but it's always a discussion. So this student wrote one paragraph to determine why hydrogen should go in the first group on the periodic table, which was only part of the activity that they were to do for this assignment. And so I'm able to quickly comment on their work and say what I need to say about their work. It's then up to them to go back on their time and continue working on the assignment. Green work activity is where they start to become an exemplar for others. So here's a student, and this is just the bottom end of her assignment. Same assignment, but you'll see the first comment wasn't even mine. Other students are going to this student for information and ideas, and they're commenting on the work that's done. And so what's great about this is it's starting to share and being able to share and publish in science is such a fundamental attitude and idea from pushing these kids forward in the realm of science. Not all units work like chemistry because not all units are chemistry, although you could argue that electricity is very, very close. What I like about the subtitle, "When Your Resources Are Better Than You," is that there's this wonderful website on physics called Furry Elephant that walks through the fundamentals and basics of electricity so well that I think I probably learned it as I was teaching it for the first time as a grade 9 science teacher, because the website was able to clear up so many misconceptions. It was animated, it was visual, it was auditory, it had everything, and then at the end of each lesson there was a summative multiple choice test that allowed the students to check in and see where they were at. So I'm not always about project-based learning. In this case, this is very much a student-led journey through the 10 lessons on Furry Elephant, followed by an activity where they were asked to create a project for a science fair. And this is where I really started to employ the flipped method. There's lots of talk and banter going on about what a flipped classroom is right now, and certainly I can weigh in on that. But to summarize what I think a flipped classroom needs to be, it needs to be meaningful work. It needs to be practical for the teacher and for the students. You need to be engaged as a teacher in what the students are doing. Students need to be engaged in what they're talking about. And most importantly, as a teacher, you have to be available. Flipping a classroom is one thing, but if you're not available to the students when they come in, then the method is completely defeated. Really, the method is to make you available. So for those of you that aren't familiar with what a flipped classroom is, you can look up the hashtag flipped class on Twitter, and there's some great resources through the people that are posting there. Basically, it's taking the classical method of let's work in class, whatever you don't finish, do at home, to why don't you go home and do this online. The Furry Elephant, for instance, go load it up, watch the first animation tonight, and when we come back to school, I'll ask you to put together a circuit based on what you learned. So they're at school working on the things that they really can't get help for at home, and they're at home doing the things that they really don't need help to do. What's great about the flip method and this whole assessment for learning thing is that peer assessment can be a way of doing a unit exam. So the neat part about the science fair is after they were finished putting together their individual assignments, their individual projects, which was basically create something that lifts an object using electricity. And be able to manipulate it and show that it's working the way it's supposed to work and make some predictions based on that. But what was neat is after they're finished working on their own, they're asked to go around and look at another and reverse engineer it. Watch their presentation, summarize what was going on, actually test that the numbers are in fact what the people in the presentations are quoting, and they're assessing their peers. And in that assessment, they're also testing their vocabulary, they're testing their glossary, they're testing all these things that they had to do on their own, and they're comparing themselves in a way that is not about who's got the highest mark, but it's who's able to communicate in a reasonable way, and who makes that communication really approachable. And I think those two are skills that all scientists should develop and practice as they go into the field. There were some unanticipated problems, it's true, with any new approach or anything that you're instituting for the first time. You can expect that you run into a few. The first and most major problem came out of individual group work. There is this collective idea that if you're looking at other people's work and writing down answers, then you're copying them and you're not really learning. If you're doing a project in a group and one person in the group is carrying you along the way, how do you make sure that everyone arrives at the same situation? And again, these things are always problematic. They can be inconclusive. and certainly you're limited in what you're able to do if you're looking for individual assessments, and ultimately it allows for students at times to be lazy. And where it comes out, unfortunately, is at the end of the project when a lazy student who's been drifting or is looking for ways out of things, or looking for people to work with who will do the work for them, they don't really get picked up until the end. And this is a classic problem that certainly is shown up in many different areas, not just this one, but it hasn't disappeared. The other one is marking load. If you look at my space unit, for instance, I had 10 I can statements. There were 25 students per class, 4 science classes, 10 objectives per unit, plus rewrites for each one of these things. It meant, and I counted them up, there was more than 1,100 assignments marked before November 1st, 2010, and that's just insurmountable. I was able to do it at the great personal cost, obviously, but it did mean I had to do some redesign really quickly. And even then, it is a bulky process, and it needs teamwork to really be effective. Teamwork amongst teachers. There were some unintentional bonuses as well doing this method, things that I didn't anticipate and showed up and I thought were really excellent. The first one is differentiation. I was looking for this, but I didn't know how it would turn up. So here's two projects turned in at the end of the year after students started to get comfortable with themselves and with their voices and with the way they wanted to work. The student on the left with the YouTube videos decided, I don't know, 2 or 3 months into the year that he was going to creatively create most of his assignments, follow a little bit different path, and he was supposed to write a letter to a business owner or to workers or to consumers to talk about the pollution that's going on in some really polluted places in the world that he had to research, in a single polluted place in the world that he researched. On the other side, it's the same project, a different location, a different student who actually wrote out the letter as an assignment and was able to break up her information, color-coded and whatnot. And what's great about this is that they're finding their voice, and they're getting the information across, but they're also realizing that they don't have to be self-conscious about it not looking the same. The sandbox is somewhere that the computer gurus at the PBWorks site that I'm using to do this said is a really important thing. It allows students to go and break stuff. Instead of your wiki, they're practicing the web utilities somewhere else. But what was cool about it was that these students went there initially to play, and then they started discussing things, and then they started discovering things not only about themselves but also about science. And I was able to weigh in on the conversation a couple of times, but I kept my fingers out of it as much as I possibly could. And certainly it started off as a place where they were just flaming each other and trolling and changing formatting and things like that. But if you give them enough time to play, pretty soon some really neat conversations and culture comes out of it. And a sandbox is something that I highly promote, having seen it work. And again, it took a couple months, but once it started, it was amazing what they were talking about. And the last bonus was plagiarism, and you might laugh and say, wait a minute, plagiarism isn't a bonus. It really worked well to have a wiki available to everyone, because now the assignments that were being copied in the cafeteria or in the hallway before students came in because they're worried about getting a homework mark or a 0 on an assignment or a late, they're now having to do it online. So student 1 submitted the little clip that I've got there. Student 2 submitted the same clip that I've got there, but because, and this would normally happen on an assignment, I wouldn't know who it should cost or who to talk to online. I can quickly pull up when things are posted, and I can quickly identify which student it was that was looking for the quick way out of the assignment, and I can go and talk to that student directly. And I was able to actually promote less. I found that there was less copying going on, and more of what student 3 was doing, which is talking about people's assignments that she was looking at, summarizing what they were saying and saying that I like what they're saying and here's why. And I think, again, as scientists, we're often asked to quote and cite and annotate from different resources and sites. And if we can train our students to do the same, that's what we're doing. Student 4 along the way as well. Conversations came up about, if you don't own the image, what do you do? And these are really, really important conversations to be having with our students as we push forward in this digital age. So going forward, I don't really know what to say, except that I appreciate where I've been, and that I'll continue to look for ways to improve the process and listen to the feedback that I'm getting from the students who are now in grade 10, 11, and 12 who've gone through these similar systems. And they're coming back and saying that, yes, they feel prepared. Yes, it was a lot of work. Yes, they really had to think, but they appreciated it. And I haven't talked to every student, and I haven't by any stretch done anything formal in terms of researching how this is playing out. But I do know that over the course of the last 4 years, there has been improvement every year on standardized test results, and that's an arm wave at best, because students are students, and every year they're a little different. But certainly, it gives me the faith that we're moving in the right direction with this kind of work. So thanks for listening, and I welcome any feedback that you wish to give.